solving systems by substitution. Solving systems by graphing is great for getting a visual picture of what you're talking about. Graph one line, graph the other line, where the two lines cross. You can visually see what you're trying to do. One line is all the xy's that work in one equation. One line is all the xy's that work in the other equation. Where they cross each other is the one that works in both of them. However, if you are not very meticulous in your graphing, or if you have a line that is difficult to graph, or they meet somewhere not at a good crosshairs, that's not necessarily the best way to do these things. So we're going to start solving them algebraically, which is what we're dealing with today. Solving by substitution.
Where's the pass?
Yes. So,
Noah, do you have the notes?
yeah, I give you those.
Okay.
Okay. So solving by substitution, the idea is fairly simple to begin with, but it is involved. So the first question we have, if y equals 4 and x plus y equals 10, what is x? Now, in order to solve this by substitution, here's what we're talking about. I know what y equals. I take this value for y, and I plug it in here. I substitute it. I take y and replace it with 4. I substitute y with what y is equal to. So now I have x plus 4 is equal to 10. Okay. That's what substitution is. That's what you're doing. You're replacing. You're taking one of the two variables and replacing it with what it's worth. In this case, it's a simple number. Y is 4, so I'm taking y and replacing it with 4. And then I solve this equation. Subtract 4 from both sides, and I get x equals 6. So what is x? X equals 6. Okay. That's substitution. A very simple substitution. So if we take a second, and look at the next one. Y equals 3x, x plus y equals negative 32. I want to know the solution to the system. By graphing, I would graph each line where they cross. I'm not going to graph, I'm going to do it algebraically so I know for sure and for certain. I don't have to worry about screwing up my graph. I don't have to worry about the lines crossing at a good spot or anything like that. Even if my answer comes out a fraction, I know exactly what it is. It does require more work. How many variables do I have there? How many variables do I have in my equations? I've got 2. I have x and y. So how many answers do I need? 2. X and y. I need both answers. One of the things a lot of students do is they'll find one and they stop. Now, I stopped on the first one because I already knew what y was. I only had to figure out x to get both of my answers. This one I'll have to do more. So I'm actually going to be doing 2 substitutions to solve this one. First one is an easy one. Y equals 3x. What's y? Y is 3x. So what's y? It's 3x. So I take y here, replace it with 3x from here. So I have x plus 3x equals negative 32. I took y, replaced it with what y is equal to. Y is 3x, so I took y, replaced it with 3x. That's the substitution part. I substituted 3x for y. Because why? Because y is 3x. Right. Now I need to solve that equation. 3x plus 3x, I get 4x equals negative 32. Divide both sides by 4. X equals negative 8. There's one answer. Okay. How many do I need? 2. So I need to figure out what y is. This is where my second substitution comes in. I know what x is. I need to find out y. So what do? Ooh, I do essentially what I did up here. I take this x, which is 8, and I either put it into my original equation. I either take it and I can put it into here, or I can put it into here. It doesn't matter which one I take that first variable and stick it into. I can put it into either equation, whichever one I think is easier. I think the top one is actually easier, because I already have y by itself. If I put it in here, I'd still have to do some more work. This one I say, ooh, y is equal to 3 times negative 8. Why negative 8? Because that's what x is. X is negative 8. Multiply this to y equals negative 24. Now I have my two answers, negative 8 and negative 24. With me so far. It's a lot of work, but you know you're getting the right answers, you're getting the exact values. If this was graphing, if these were two fractional answers, you'd know you had the right fractional answers. I'm not going to do that to you, but that is something that can happen. Now the next one we have issues with. In order to be able to do substitution, you have to have one equation has to be y equals something or x equals something. You have to have one of those two conditions. You have to have y by itself or x by itself before you can substitute. I had that here in this first one. I had y equals 3x, so I could do my substitution straight up. I had that here, y equals 4, so I could do my substitution straight up. I don't have this here. I don't have y by itself or x by itself. So I have an extra step I have to do. I have to get y by itself or get x by itself. I have to rearrange one of those two equations. Now, when I look at that, I want to figure out, am I going to have fractions to deal with or not? Which equation will I want to rearrange first? Because I could technically do either one of them, but one of them is going to make my life a lot harder than the other one. And if I look at this one, I go, okay, let's say if I solve this for y, I'm going to have to take 4 divided by 3 at some point. It's going to give me a fraction. 12 divided by 3 is okay. If I solve this one for x, I'm going to have 3 divided by 4. It's going to give me a fraction. I don't want that. If I do this one, every single one of these is divisible by 2. I'm not going to have any fractions to deal with. Okay, so I'm going to rearrange the second equation. And I'm going to solve for y. Because I think y is going to be a little easier, but it doesn't really matter which one I do. So my first step, I'm going to take the second equation and solve it for y. So I add 2x to both sides. And this is just like what you had to do for graphing. Same idea. So the 2x's here cancel. I get 2y equals 2x minus 6. So once again, I cannot combine them together. Right? It is not 4x. It's not 8x. It's 2x minus 6. This one has x's and one does not. My next step. I want to get y by myself. What's the next step?
Divide by 2.
Divide by 2. Divide everything by 2. I get y equals 2 over x divided by 2 is x. 6 divided by 2 is negative 3. This is not my answer, but this is what I need to have to be able to do my substitution. So I have y equals Okay. So I need to substitute. I can't take the equation, cannot take this and put it back in the equation I rearranged. It has to go in the other equation. This has to go in here. And just the y. This is probably one of the first mistakes students make. I'm not replacing 3y, I'm replacing y. So the rest of that equation stays the same. The rest of the equation, except for the y, stays the same. I had y here. What do I replace it with? I replace it with x minus 3. That's my substitution. I take y and I substitute in x minus 3. No more y in that equation. It's substituted. When I'm not here, you have a substitute. You don't have me and the substitute in the room at the same time. You don't have y and x in there. If I substituted for y, the y is gone. It's replaced with something else. They're not there at the same time. And now you solve for x. Okay, and we've done equations like this. They are involved, but we've done them before. Distribute to 3. 3x minus 9 plus 4x equals 12. Combine up my like terms. 7x minus 9 equals 12. Add 9 to both sides. 7x equals 21. Divide by 3. X equals 7. Or sorry, divide by 3. Divide by 7. Oh my god. Divide by 7. My bad. Divide both sides by 7. X equals 3. I'm getting ahead of myself. Am I done? How many answers do I have? I have 1. How many do I need? 2. Now, here's the thing. X equals 3. That means in any equation that I have that has both x and y, I can put 3. I can take this first equation, I can put 3 here. I can take the second equation, I can put 3 here. But I can also go down here and into this equation and put 3 in here. Which one's easier, the first one, the second one, or the third one? Which one's going to require less work? The third one. I'm not stupid. I'm going to take this and put it into here. I'm going to do the easiest one possible. So y equals 3 minus 3. What's y? Oh, come on. This is an easy one. What's y? It's 0. And do not panic if you get 0 for a number. That's perfectly fine, perfectly acceptable. Too many students get upset. Oh my God, it can't be 0. Yes, it can be 0. 0 is great. 0 is a perfect number. 0 is a fantastic number. Okay. Even has a song for itself. Might play it for you someday. Okay. Questions? Okay, the next one's a little bit more difficult because it's a word problem. But this actually is not a difficult word problem. Well, yeah, it's not easy. So, using systems of equations. A snack bar sells 2 sizes of snack packs. A large is $5 and the small is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did they sell? So my first thought is, okay, we need to find somebody else to run the snack bar if they can't keep track of how many of the different items that they sold. That's my first thought. Whenever I read these problems, I go, okay, whoever it is, if they have to make themselves do algebra to figure out how many of each they sold, rather than keeping track, They're not that bright. Okay, so yes, in reality, this is not a great question, but it does work good for what we're trying to do here. I have two things I'm looking for. My large and my small snack bags. I'm going to call large as X, and I'm going to call my smalls Y. This is a very, very typical question. This is one that is asked all the time in algebra books. It's one that's asked all the time in algebra problems. It's an extremely common question. And I will always have two equations. One equation is for how many? X is the number of large ones sold. Y is the number of small ones sold. So I take how many large plus how many small. How many did I sell altogether? How many did I sell altogether? 60. I stole 60 altogether. So that's the question of how many. The number of smalls plus the number of larges equals 60. Second equation is how much? How much is it worth? What's the dollar value I'm dealing with? How much do larges cost? $5. So 5 times the number of larges I sold is how much money I made off of the large bags. How much do the small ones go for? $3. So that means plus 3Y. How much money I made off of that? 3 times the number of smalls is how much money I made off of the smalls. How much money did I make altogether? $220. So I add how much off the large plus how much the small I get, $220. There's my system. One equation for how many bags I sold. One equation for how much money I made. This is an extremely common question. Very, very, very common question. I see it all the time. Every textbook's got a dozen or more of these. It's one of those ones, it's a classic algebra problem. And it's always how many and how much. Okay. Now, you might have one or two of these on your classwork. We're going to be doing more of these in a few days, and we'll just do some applications. So, I need to solve. I need to figure out how many of the small ones I have. Which means I need to figure out which variable do I need to find. Y. I need to look for Y. I need to find Y. So, once again, I have to rearrange one of these equations. I'm going to rearrange the top equation because it makes more sense. Because if I'm looking for Y, I rearrange the top equation. So I take X plus Y equals 60. And I want Y by itself, so I subtract X from both sides. Actually, no, I want that one backwards. My bad. I subtract Y from both sides. And you'll see Y in a minute. So X equals 60 minus Y. Because when I do my substitution, I'm going to take this X and replace it with Y. No more Y's. So I take this and I plug it in there. So I have 5 plus 3Y equals 220. And what is my X? My X is 60 minus Y. Now I have to solve. First step, distribute the 5. So I end up getting 300 minus 5y equals, plus 3y equals 220. Combine like terms. 300 minus 2y equals 220. What's my next step? Subtract 300. So I want to get y by itself, so I subtract 300 from both sides. And unfortunately, I'm running out of room here, but I get negative 2y equals negative 80. I'm going to move this over here. Negative 2y equals negative 80. What do I do next? Divide by negative 2. And y equals 40. So I solved 40 for the small ones. Yeah, there's a lot of work involved in these. Substitution is probably one of the ones that requires the most amount of work that you're going to be doing. But substitution is also something that you do continuously afterwards. It's not just for this. This is actually something that's extremely useful. Okay. Same idea, solving by substitution. However, the answers for these two are special. Now, first thing when I'm solving is I need to have x by itself or y by itself. In one of those two equations, do I have x equals or y equals? Do I have x equals or y equals in one of those two equations?
X.
I have x equals in the first one. Makes my substitution easy. I take this and I put it in for that. Negative 2y plus 4. So, solve it. Distribute the 3.5. Gives me negative 7y plus 14 plus 7y equals 14. Combine up like terms. My like terms are negative 7y and positive 7y. What's negative 7y plus 7y? 0y. There are no y's. They're gone, right? Negative 7, positive 7 cancel each other out, so I get 14 equals 14. Do I have any variables in there? No. When your variables drop out and you have a true statement, what kind of statement is this? This is a true statement, which means I have infinite solutions. If we were graphing, these two lines would be the same line. That's what this is. Algebraically, these are two lines into the same line. All the variables drop out. I have a true statement. They're the same line, infinite solutions. Any x, y that works in the first one will also work in the second one. Second one has the same idea. I need to solve the problem. I have y equals 3x minus 11. So I take this 3x minus 11, put it in for y. The rest of it stays the same. Combine like terms. What's 3x minus 3x? Nope, 0x means no x's. So I get negative 11 equals negative 13. Does negative 11 equal negative 13? No, this is false, which means there are no solutions. Okay, no solutions. If everything drops out and it's not equal, that means you have two parallel lines. There are no solutions. Okay, this will happen from time to time, not very often. Questions? Yes, a lot of work.